Alright, my name is Evan, and here's my tutorial for how to make a weather system with a global material either in UE5 or UEFN. I'll do a step-by-step here in the video, and if you want the project file to mess around with, you can follow my Patreon, which I just started, in the description. Alright, here we go. So, I just have a simple plane right here, and a material called ground material. As you can see, it's pretty simple, just a color, roughness, and normal that we have plugged into the material over here. So in making a weather system, the three attributes that we're going to be messing with is the base color, the roughness, and the normal. The way we mess with them is the base color, when things get wet, it gets slightly darker. That's all we do to the color. The roughness, we have both puddles and an overall wetness that we add to it. And for the normal, we just flatten where puddles are and where the water is deep enough that it wouldn't have the normal from the original material. So you might start messing around with your original material, but that'd be incorrect. We want to make a global system that can affect multiple materials and affect everything in our level without having to animate multiple materials. So the way that we would do that is first, let's make a material function. So material function is just like you're making your own node that you would plug into the normal material graph. And so just like a node, you have to have inputs and outputs. So for our outputs, we're going to have 3 outputs, and you look up just function output. And let's name these color, roughness, and normal, because those are the 3 attributes we're going to be changing. And for priority, do 0 for color, 1 for roughness, 2 for normal. Now we're going to need our inputs. Function input. Just bring these in here and do color, roughness, and normal. Now let's just connect these. Simple like that. And then boom, we now have our material function. Alright, so now we have our simple material function set up. The last thing to do is make sure you click expose to library here. What this does is, because we're just making a node to be used in the material graph, if you right click right now and search your function, mine's called weather tutorial, it does not show up. But if we just click expose to library, now we can search up in any of our materials this weather function and drag it in super easily. So we bring it into our master material, and all you gotta do is simply plug in color, roughness, and normal, and then color, roughness, normal. Now it seems I did the input priorities backwards, so we're gonna quick go in here, or maybe I just didn't set it at all. So we're gonna do 0, 1, 2 again, and now everything should be lined up correctly. On first glance, it doesn't do anything because we're not changing these values at all. So now what we're going to do is create the changes that our function does to each of these values, the color, the roughness, and the normal. And what we're going to use to make these changes, so usually you can press 1 and click 2, 3, and bring in parameters into your material function. But what we want for this function is global parameters that will be changed throughout all of your materials that are using this function. So what we use for that is right click in your content browser and search material parameter collection. And we're going to name this weather params. And what this material parameter collection is a nice place where you can store parameters and then call them in anywhere in the material graph. So you can either do scalar parameters or vector parameters. Right now, we're just going to make 4 scalars, and we're going to name these puddle size, puddle amount, overall wetness, and wetness darken multiplier. So these are pretty self-explanatory, but now when I save this, we can go into our function and search collection parameter, select our collection, weather params, and then we can choose any of the parameters that we just created, and then they are now referenced in this material function and then referenced in your base material. And the nice thing is that then we can animate these values over time later. But for now, we're just going to set up this material function. So the first ones we're going to set up here, we'll do overall wetness and wetness darken multiplier. And then around the roughness area, we'll do puddle amount. We're going to also reference puddle amounts for the normal, so we can do our normals. And then back here, we're going to reference puddle size. So the first thing let's make our puddle mask. And what this is just, we're going to reference a texture that will tell our material function where to put puddles and how dense those puddles are going to be. So first off, let's clamp the puddle size value to between 0.1 and 1. The reason you do this is 0 glitches out for the puddle size, so we're just going to make sure it's always at least 0.1. Then multiply. We're going to multiply by 500. So whenever I either multiply or divide these values by a big amount that isn't a parameter, like this I just put in a static value of 500. This is basically so that the material parameter collection, all the parameters can be between 0 and 1 always. So when I multiply by 500, that just means that the value that I actually want from the puddle size parameter ends up being 0.1 times 500 or between 1 and 500. But to make it easier for users, we're just going to have them make sure that all the parameters are just between 0 and 1 because that's easier for whoever's using it. Now we're going to divide and then take a texture sample. So normally you just take a texture coordinate and plug it into these UVs, but because we want the puddles to be global and go across materials, what we're going to do is take our world position instead, mask it, or you can just take the XY, divide by 10. Again, this is just one of those numbers that is for user friendliness and to make everything look correct. And then now our puddles will go between different objects and they will be consistent throughout our entire map, no matter what. So for our texture sample right here, we're gonna have our puddle mask. I just looked up puddle mask on Google Images and got these two. But yeah, just make sure you have a seamless puddle texture right there. And now right here, we can comment this out because this is our puddle mask. This is just where all the puddles are supposed to be throughout our material function. Then the next thing that we're gonna do is with the normal, we want to flatten wherever the puddles are. And now we can do this that we have our puddle mask. So we take our input normal and we're going to have a flatten normal node right here because that's how you flatten. And then combined with our puddle amount, we're going to do multiply by 2, another multiply, taking our puddle mask. So we're multiplying our puddle mask by the puddle amount, which is the parameter. Then we're going to clamp it between 0 and 1. Another node you can use besides clamp, if you're just going between 0 and 1, is saturate. That does the same thing. And then we're going to plug this into the flatness, and then we already have our normal plugged in, and then we can output our normal. So what this does is it takes our puddle mask again, takes our puddle amount, multiplies the mask by the puddle amount, and then flattens that normal where all the puddles are. And so now the next thing we have to do is take into account our overall wetness and our wetness darken multiplier. And what we're going to do with these values is, again, clamp both of them. For the wetness darken multiplier, we're going to clamp between 0.01 and 1 because, again, when this value gets to 0, it just doesn't look good. So we're just making sure that our users have a less margin for error when they're using it. Then we multiply this one by 0.2. And so now what we're going to do is we're going to mess with our roughness. Make sure that we subtract roughness where the puddles are so that the material is now shiny where the puddles are supposed to be. So we take our input roughness, let's drag these back here. And roughness 0 is full reflection and 1 is no reflection. So whenever we're adding reflection to our material, what we're going to be using is subtract. So take our roughness, one subtract node, another subtract node, and then at the end, again, we're just going to clamp it between 0 and 1 because roughness only goes between 0 and 1. And then for puddle amount, we'll multiply by 3. Then a multiply node. And then we are going to plug this multiply into the subtract right here. We can connect the clamp to the end to our output. And then what we're going to take is we take our puddle mask right here and bring it into actually the top multiply of this one. So we're going to change these around. And then we are going to take our overall wetness that is clamped. We're going to divide it by 2. And then that's what we're going to subtract right here. So what we have going on here, I'm going to move this like this actually. So what we have going on here is we have our overall wetness that we are subtracting from the roughness to make sure that everything gets an overall sheen and reflection depending on how much overall just rain there is on the ground. Then the next thing we subtract is again our puddle mask multiplied by the puddle amount. Same thing is going on over here. So first overall, then we subtract where our puddles are, and then again we clamp, and then our roughness should be good to go. Now the last attribute we have to do is the color. So what happens to color when things get wet is they just get slightly darker. That's all we're going to do to the color, is we're going to take our overall wetness and our wetness darken multiplier, multiply the two of them, and then we take our color, subtract this overall wetness, then we're going to do another subtract, and we're going to take again our puddle mask multiplied by the puddle amount. Boom. And then we can plug that into the color. So this is slightly messy. Let's clean all this up to make it make more sense. Again, puddle mask right here. Here's the roughness calculation, so we can comment this out. And then right here, we can just call this darken where wet. And here, let's organize all this a little bit. And then we can call this flatten puddles. All right, so save that. And now, because we have this connected in our master material again, now we just need to change these values to make the puddles start appearing, because still it looks the same as before. So let's bring up our content browser. We're gonna make a level sequence, tutorial, open up that sequence, and then you can add material parameter collection. So let's go to our weather params, because that's the one we just made. And then when you press plus, you can see all the parameters that you created here, and now we can animate them in the sequencer. So let's add each of these here. So the ones you can animate, puddle amount, overall wetness, and wetness darken multiplier, you can animate these. Puddle size, you cannot animate because it looks slightly weird. I'll show you what that looks like. First of all, we'll just animate these all from 0 to 1. All right, so make sure you apply. When I was doing that, I wasn't doing anything because I didn't have the changes applied. But now, as you can see, over time, these parameters are all animating. Now, obviously, as you can see, yeah, when the size gets animated, it doesn't keep them in the same spot. So we're not going to want to animate the size. Just find a nice size at the beginning that you want to keep your puddles at. Or we can put at the end so you can actually see what they look like. Something like this. And just like that, now you have a system where you can animate puddles, wetness, rain showing up on the ground. And the amount you can make even go higher than one if you want. It kind of loses contrast at that point, but just find your nice sweet spot. You can get rid of the overall wetness. And then combined with something like a particle system, you've got a pretty good weather system going right here. And this can, if you put this on your master material that you make instances of, these effects will be applied throughout all the instances and thus throughout your whole map. So this technique promotes good material practices as well as lets you have some awesome global attributes that you can change for your whole level. Obviously, this is not going to be included in the project file because this is a separate map that I'm working on, but I'll show you how I use this global material system here. This is my map Haven. You can play it in UEFN. And so I have a weather system. I have all these sequences for each weather state. And then, as you can see, everything over time can get wet or go away.